Hello Devices 2, this is Professor Late. This video is going to cover Lab 5, the operational amplifier known as an op-amp. First we're going to cover the inverting op-amp. First thing we're going to do is build that circuit and then use that circuit to fill out table 1. Here you can see the built circuit. We have RR1 set for 10 kiloohms and RF1 set for 10 kiloohms as well. For our oscope, we have channel A reading the volts out and channel B reading the volts in. So I've run the oscope on this, and you can see that the output, which is channel A, you see that there's a difference of 200 millivolts. The input also has a difference of 200 millivolts. So we were to calculate the gain, voltage out over voltage in, we would have a gain of 1. And you can see that our input sine wave is 180 degrees out of phase with our output sine wave. So that's how we're going to run the rest of this lab, changing out the RR1 resistor to the values you see in that second column in the table. So we'll go on to the 5 kiloohms next. So here we have it with 5 kiloohms for our RR1. You could see that our output voltage is now at 402 millivolts, whereas our input voltage stayed at 201 millivolts. So if you define the gain, you divide the voltage out of 402 by the voltage in of 201. And that'll give us a gain of 2. You could also see that the input sine wave and the output sine wave are 180 degrees out of phase. Next, we change the RR1 to 3.33 kiloohms. You can see that our output voltage is at 603 millivolts, and our input voltage stays at 201 millivolts. So if you calculate the gain, it would be volts out, which is 603, over volts in, which is 201. So that gives you a gain of 3. You could also see that the input sine wave is 180 degrees out of phase with the output sine wave. Next, we have our RR1 at 2.5 kiloohms. You can see that our output voltage is 806 millivolts, and our input voltage is still at 201 millivolts. So to calculate the gain, 806 divided by 201 gives us about a gain of about 4. And you can see that still the input sine wave is 180 degrees out of phase with the output sine wave. Next, we're going to measure with our RR1 at 20 kiloohms. You can see that our output voltage is at 100 millivolts, and our input voltage stays at 201 millivolts. And to calculate our gain, we're going to divide our output voltage by our input voltage. So our gain is about 0.5. And you can see that once again, the input sine wave is 180 degrees out of phase with the output sine wave. And then for our last measurement on table 1, we're going to have our RR1 set to 30 kiloohms. And you can see that our output voltage is 67 millivolts, whereas our input voltage is still at the 201 millivolts. So to find the gain, you divide the 67 by 201, and you end up with 0.333 repeating. You can still see that our input sine wave is 180 degrees out of phase with our output sine wave. Next, we're going to build our non-inverting op amp. We're going to build this circuit. And then we're going to use the findings from that circuit to fill out table 2. So with our RR set to 10 kiloohms and our RF1 set to 10 kiloohms, you can see that our output voltage is at 402 millivolts and our input voltage is at 201 millivolts. So to calculate the gain, you divide 402 by 201. That gives you a gain of 2. You can also see that the input voltage is in phase with the output voltage. So now that we've set the RR1 to 5 kiloohms, we can see that the output voltage is 603 millivolts, and the input voltage is still at 201 millivolts. So to calculate the gain, you divide 603 by 201, and that gives you a gain of 3. You can see that our input sine wave is in phase with our output sine wave. With the RR1 set to 3.33 kiloohms, you can see that our output voltage is 804 millivolts and our input voltage stays at 201 millivolts. So to calculate the gain, divide the 804 by the 201. And that gives you a gain of 4. You could also see that our input sine wave is in phase with our output sine wave. So now with our RR1 set to 2.5 kiloohms, you see that our output voltage is at 1 volt, whereas our input voltage is still at 201 millivolts. So to calculate gain, you divide 1 volt by 201 millivolts. That gives you a gain of about 5. You can still see that our input sine wave is in phase with our output sine wave. So now we've changed the RR1 to 20 kiloohms. You see that the output voltage is 302 millivolts, whereas the input voltage is still at 201 millivolts. Calculating gain, dividing 302 by 201, you find that the gain is 1.5. And you could also see that our input sine wave is in phase with our output sine wave. And finally, when we set our RR1 to 30 kiloohms, we see that our output voltage is 268 millivolts, and our input voltage is still the 201 millivolts. To calculate gain, divide 268 millivolts by 201 millivolts. And that gets you a gain of about 1.33. You can see that our input sine wave is in phase with our output sine wave. And so that concludes our lab number 5, the operational amplifier, or op amp. So make sure you fill out the tables and write up your conclusions. This has been Professor Late. I hope you have a corona-free day.